Let's summarize the most important events in spaceflight in the past days. This episode will focus on progress in preparation of the American Europa Clipper spacecraft, which is going to study the icy moon of Jupiter, Europa. Then, we will take a closer look at the preparation of new and powerful upper stage for the SLS launch vehicle. Finally, we will cover the current state of the European Euclid Telescope. Next year, the Falcon Heavy launch vehicle is scheduled to launch the US Europa Clipper spacecraft designed to survey Jupiter's moon Europa. With help of the whole set of advanced scientific instruments, the spacecraft should find out what conditions are on the surface of Europa and in its vicinity. The main focus will be on finding out whether there is a potential for sustaining life. The probe is equipped with a suite of cutting-edge instruments, which is expected to generate significant amount of high-quality data. Since the spacecraft will travel several hundreds millions of kilometers from Earth during its mission, transmitting such a large amount of data will not be an easy task. This is a result of several years of work of a team of experts, a high-gain antenna for the Europa Clipper. With its diameter of 3 meters, it is definitely not dinky. The antenna was attached to the spacecraft's body on the 14th of August in a clean room of NASA Jet Propulsion Laboratory in California. The Europa Clipper is equipped with several antennas, but the high-gain antenna is by far the biggest one of them. Although its beam width is very narrow, it is capable of transmitting huge volumes of data. If you're interested in current activities in Jet Propulsion Laboratory cleanroom and would like to observe NASA experts during their work, you can take advantage of webcams located in JPL and watch livestream on YouTube. On August 1st, we notified you regarding the transportation of the final ICPS upper stage to the Florida spaceport. We concluded by expressing that, commencing with the Artemis 4 mission, US SLS rockets would begin utilizing the newly developed EUS upper stage. I had promised to provide further information on this stage at a later date. Today, I am fulfilling that promise. The Exploration Upper Stage, also known as the EUS, has already been approved in design, yet a number of tests must be conducted prior to the commencement of production of flight hardware. These photographs were taken in July at the Michoud Assembly Facility near New Orleans and depict the preparation of the oxygen tank dome of the EUS test article. It is important to note that this is not yet flight hardware. This component, in addition to others, will form part of a weld confidence article designed to verify that the welds meet specific requirements. How will the EUS differ from the current ICPS upper stage? This infographic illustrates the main distinctions. The larger tanks and higher number of rocket engines signify that the SLS launch vehicle's payload capacity to the moon will increase by 40% when utilizing the EUS upper stage. This will enable the SLS deliver not only the Orion spacecraft itself to the moon, as it is capable these days, but also an additional cargo. In the case of the Artemis 4 mission, this would be the IHAB habitation module for the Gateway space station in orbit around the moon. The European Euclid Telescope, designed to investigate dark energy and dark matter, has experienced several eventful weeks. Following its launch on the 1st of July, the Euclid Telescope has been subject to a series of tests and calibrations of its onboard systems and science instruments. Its optical system was also successfully focused by subtle adjustments of the secondary mirror. After approximately 4 weeks, the Euclid successfully achieved orbit around the L2 Lagrange point of the Sun-Earth system. The VIS instrument for visible light and the NISP instrument for the infrared part of spectrum work perfectly. Experts have evaluated that both of them meet and in some cases exceed the stringent requirements. The VIS instrument does occasionally suffer from interference caused by scattered sunlight. However, this can be remedied by a change of the telescope's orientation in relation to the Sun. Euclid has now moved on to a new phase, performance verification. This phase will rigorously assess the telescope's capacity for gathering copious amounts of data. The operations team will control the telescope in the same manner as is necessary for scientific observations. The repositioning protocols that will be implemented during the 6-year science service will be simulated, and the telescope will also be evaluated for extended observations of a single region of the sky. The mission team will utilize these preliminary observations to analyze in depth the parameters exhibited by the instruments. Calibration processes can then be formulated based on acquired information. If you appreciate our videos and would like to be notified of new releases, simply subscribe. Additionally, giving a video a thumbs up will inform YouTube that you would like to view these videos more frequently. New episodes of Spaceflight News are now published every 3 days, so the next one will be available on Saturday, August 19th.